see the screen now? No. Okay, so we have in the last class we have completed about these atmospheric ocean coupled phenomena like your Madden-Julian oscillations, Indian Ocean dipole, and your El Nino southern oscillations. Some other oscillations are also there. I have mentioned it about in the last class, like the North Atlantic oscillations and quasi-Benelian oscillations. Okay, these two oscillations we are going to complete when we specifically go for this climatology. Okay. For now we have completed these phenomena, very important phenomena, highly affecting the Indian climate, Indian monsoon. ठीक है, तो इसको आप ध्यान रखिएगा. So अब इसके बाद आप आते हैं यहाँ पर deep ocean currents में. So whatever things we have studied about this much point, ठीक है ना, this much slides are totally dedicated to the shallow water currents. Now we see what are deep water currents. ठीक है. So I can so you see as the deep water, so that means they are deep, but how much deep? ठीक है ना. So we have studied about this mix zone, pycnocline, halocline, thermocline. ठीक है ना. So below this thermocline, whatever water flows below this thermocline or a pycnocline, is considered to be the deep water current. So it is mentioned here. And so they influence about 90% of all ocean water. ठीक है. तो ये आपका पूरे ओशन से इफेक्टेड रहते हैं. मैंने आपको एक बात बताया था कि जो भी आपका डीप वाटर में क्या होता है, सेडिमेंट ट्रांसपोर्ट होता है, उसमें इन करंट्स का बहुत बड़ा रोल है, डीप वाटर करंट्स का. दो दे आर वेरी स्लो, ठीक है ना, वेरी स्लगिश कंपेयर टू द your shallow waters. ठीक है. Then your density differences are the main prime thing through which these deep water currents are driven out. So ultimately density difference are being created because of salinity and temperature. Because of salinity and temperature. Deep water moves large volume, very large volumes of water. Compared to the counterparts, they carry very large volume of waters. ठीक है ना. But they are more slower.
Sir, please share the screen.
क्या कह रही हैं आप?
No, sir, no.
Okay. But they are more slower.
Sir.
बताइए. So they are much slower. Much slower means few centimeters, few meters per day. ठीक है ना, per day. So you can see that deep water currents range from 10 to 20 kilometers per year. This much slow. Few meters. They are just traveling few meters per day. ठीक है. So अब आप कंपेयर करिए, just compare that to the Gulf Stream, which moves around 100 km per hour. It is one of the fastest flowing currents. One of the fastest flowing currents, 100 km per hour. ठीक है. So अब जितना Gulf Stream एक घंटे में ट्रेवल करती है ना, उतना तो ये लगभग 5 साल में कर रहा है. It is 10 to 20 kilometer per year, not day, not hour, per year. This much slow. So you can expect it takes so much time to cover the whole globe. So much time, like not whole globe, latitudinal wise. I'm saying from north latitude in the northern hemisphere to the south latitudes in the southern hemisphere. ठीक है ना. This much time, years लगते होंगे. They are like around I think 1000 of kilometers, like 20,000 किलोमीटर, 30,000 किलोमीटर, कितने साल लगते होंगे उन वाटर्स को रीच करने में. So these are, obviously I have told you, salinity and temperature driven. Saline लिखते हैं मैंने, salinity and temperature driven. ठीक है. So they are referred to as thermohaline circulation. तो इसको क्या बोलते हैं? थर्मोहालाइन सर्कुलेशन. तो आपने अभी सरफेस पढ़ा. जो डीप वाटर करंट्स होते हैं ना, उनको बोला जाता है ये सर्कुलेशन को थर्मोहालाइन सर्कुलेशन. यह बात याद रखिएगा. तो आपके ये वाटर्स जब सिंक करते हैं, आपके क्या हुआ, ये आपके वाटर्स जो है आपके हाई लैटिट्यूड्स पे जब आपके सिंक करेंगे, है ना, तो सिंक करने के बाद ये अब धीमे धीमे आपके ट्रेवल करेंगे इन डेप्थ बहुत ज्यादा. ठीक है. सो द ओरिजिन ऑफ थर्मोहालाइन सर्कुलेशन. सो डीप ओशन करंट्स ओरिजिनेट्स एट हाई लैटिट्यूड एट द सरफेस. ठीक है. तो कहां से आता हाई लैटिट्यूड से. यहाँ पर क्या है आपका, सरफेस वाटर बिकम्स कोल्ड एंड इट्स सैलिनिटी इंक्रीजेस एट एज आइस फॉर्म्स. ठीक है ना. Surface water becomes dense enough, it sinks, initiating deep water currents. Okay. तो यहाँ पर आपकी जो हाई लैटिट्यूड्स हैं या पोलर रीजन्स, तो आइस फॉर्म होती जा रही है. आइस फॉर्म होती जा रही है, इट मीन्स रिलेटिवली द सॉल्ट कंटेंट is increasing in the water. They are becoming more dense and they are cold also. So that is why they usually sink. Sink करेंगे वो, और सिंक करने के बाद वो और ग्रेटर डेप्थ्स पे पहुंच पाएंगे. ठीक है ना, बहुत ज्यादा ग्रेटर डेप्थ्स पे आपके पहुंच पाएंगे. ठीक है. तो अभी यहाँ पर हम लोग ये देखेंगे कि यहाँ पे आप देखिए, तो उसको मैं इसको एनलार्ज कर दूं जरा. हाँ, see this. So here you have temperature, here you have salinity. These are the different ISO cores, I think, means lines showing equal density. So you have less density here and more density here. As you see that this is the diagram that we are talking about, the question. So this is the thing. अब आप ये समझिए कि कैसे इस चीज को समझना है. जैसे कि आप ये different ब्लॉक्स देख रहे हैं. ठीक है. So that represent different types of deep water currents, and what they are mentioned about this density range actually of that particular deep water current. So you have AAIW, which means Antarctic Intermediate Water. Then you have NACSW, so North Atlantic Central Surface Water. This is the central surface. Then you have MIW, Mediterranean Intermediate Water, NADW, North Atlantic Deep Water, and AABW, Antarctic Bottom Water. So these are the different types, and you see the range. Usually we take density nearly 1.013 or 1.014 for the surface, but you see it is like 1.025. And it is still changing on the third decimal place, you can see, but that change is also very huge. That change is also very huge, from 1.0245 to 90. Okay, up to 90. Here you have more salinity. Here the temperature is also decreasing, so you can expect here there would be more salinity. ठीक है. आप चीज को ध्यान रखिएगा इसको. Next, once the water sinks, the temperature and salinity remain largely unchanged for the duration it spends in the ocean. ठीक है ना. अब क्या है, once the water sinks, इसका मतलब क्या हुआ कि अब आप समझिए जो भी पैरामीटर्स जो इन्वॉल्व होते हैं डेंसिटी या फिर सैलिनिटी या फिर टेम्परेचर को चेंज कर, वो तो नहीं है, मतलब स्पेसिफिकली बोला जाए कि डेंसिटी को चेंज करने के लिए वो तो अब चले गए फिजिकल प्रोसेसेस जो होते हैं। अब डेप्थ में क्या हुआ, जैसे वो डेप्थ में गया ऐसे कुछ चेंज होते नहीं, तो उसकी वजह से वो अपनी जो भी डेंसिटी होती है उसको आपको रिटेन रखते हैं बहुत समय तक, ठीक है ना। तो डेंसिटी अल्टीमेटली किस पे डिपेंड होती है, मैंने बताया आपको, टेम्परेचर और सैलिनिटी पे। तो सरफेस पे रहेगा, चेंज हो जाएगी उसकी, लेकिन जैसे ही वो सिंक हो गया, डीप वाटर में गया, तो उसकी चांसेस कम है, ठीक है ना, उसकी सैलिनिटी चेंज होने के, बिकॉज अल्टीमेटली इट इज बीन ड्रॉन डाउन। और फिर बहुत टाइम लगता है, टेक्स थाउजेंड ऑफ ईयर्स ऑफ टाइम दैट द सेम पर्टिकुलर वाटर मॉलिक्यूल विल कम अप, है ना, इन द शैलो वाटर्स एंड बिकम अ पार्ट ऑफ द शैलो वाटर्स। अगर वो एक डीप वाटर का पार्ट बन गया तो डीप वाटर की जो साइकिल होती है बहुत ज्यादा टाइम टेकिंग होती है। शैलो वाटर की या मे बी few months or years, but deep water may be thousands of years. Okay, this is the thing. Okay, so these are the some of the important deep water. So you have Antarctic bottom waters, North Atlantic deep water, and Antarctic intermediate water. So this is, these three are more important. In this you have seen that five are given, in which these three are important. So you have Antarctic bottom water, the densest water in the open ocean. It is one of the most densest. This one. So it is touching 1.0280. Okay, so it is most densest. So sometimes question being asked that arrange these different waters, deep water currents according to their density. So you can do so by looking at this. So you have this, then this. So you have to read the diagram in this manner, diagonally. Okay. So if I say that this is AABW and NADW, then you have Mediterranean intermediate waters, then you have this Antarctic intermediate waters, and on here also, if we see that, if we compare both these, this green color and this orange color, then obviously it seems that it is more less denser, because it is touching this. Actually, I forgot what are the lines of equal density are known as. Maybe isopores. Just forgot. Maybe isopores are lines of equal volume. Okay, this particular line. So you have this AAIW and you have this NACSW. Okay, so NACSW has a very extended density variation. You see that it is starting from this much to up to this much. So a single current have this much variation. ठीक है, तो ये चीज को आप ध्यान रखिएगा. So once the water sinks, the temperature and salinity remains unchanged for the duration it spends in the deep ocean. ध्यान रखिएगा. तो जैसे अब वो गया, वो बहुत टाइम लगेगा उसको वापस आने. ये चीज मैं बता रहा था. फिर यू हैव एंटार्क्टिक बॉटम वाटर्स. एंटार्क्टिक बॉटम वाटर्स में आपका ये कहाँ बनते हैं आपके, दे आर डेवलप्ड your near your the continental slopes of Antarctica, where your freezing cold water which is having high density sinks. ठीक है, तो आपकी कॉन्टिनेंटल स्लोप एट अंटार्कटिका, तो ये आपको पता चल गया कि इनका ओरिजिनेशन कहाँ होता है. देन यू हैव नॉर्थ अटलांटिक डीप वाटर. तो ये आपके नॉर्वेजियन सी, जो आपका जो एरिया है ग्रीनलैंड और नॉर्वे के बीच में, वहां पर, ठीक है ना, वहां पर आपके सिंक होते हैं. देन यू हैव दिस अंटार्कटिक इंटरमीडिएट वाटर. अंटार्कटिक इंटरमीडिएट वाटर में आपका बता दूं, ये आपके सिंकिंग या फिर अंटार्कटिक कन्वर्जेंस की वजह से, जो आपके डिफरेंट जगहों से आपका पानी आगे कन्वर्ज होता है और डाउनवेल होता है, ये वहां पे आपके फॉर्म होते हैं. तो ये है इंटरमीडिएट वाटर. एंड देयर इज वन कॉल्ड द मेडिटेरियन इंटरमीडिएट वाटर. दैट इज आल्सो समटाइम्स इंपॉर्टेंट because those type of intermediate waters are formed because of the evaporation that take place in the Mediterranean Sea. It is not mentioned here, but I am telling you. ठीक है, because it is mentioned here, and sometimes they will give the option as Mediterranean intermediate water also, MIW. Okay, so you have to remember these like which is more denser and which is less denser. You have to read the diagram in this manner. Okay, so you have this one, this one, this one, this one, this one. ठीक है, ये आप ध्यान रखिएगा. Okay, now you see the section. Okay, so they have shown a section from Iceland up to the southern part, like up to the Antarctica. So you have this Greenland on this side. Yeah, up to from Greenland you can take, from Greenland Antarctica here. So you have this Atlantic Atlantic deep water, you know, and you have these two type of currents. One is your because of those convergence, ठीक है ना. तो आपका ये कहाँ होता है, यहाँ पर. It is mentioned here that the density is around this at 4 degrees Celsius, because at 4 degrees Celsius the water is most densest. तो यहाँ पर आपका, ठीक है ना, a little bit far away from the Antarctica, and you have this zone which is just the continental zone, continental shelf of the Antarctica. Here you have found this bottom waters. Okay, so in between you can see that this North Atlantic deep waters are upwelling. ठीक है ना, like this, in this manner. Understood? And they are dwelling like this. This one is dwelling like this. So अगर आप देखा जाए तो सबसे नीचे आपका you have this Antarctic bottom water. Understood? Then you have this North Atlantic deep water, Antarctic intermediate water. Okay, so you can see that in these locations the water is downwelling and upwelling. This is because you have a thermocline and a pycnocline that is developed in lower latitudes, not lower latitudes, better to say 70 to 70 or 60 to 60. Okay, let's say 65 to 65 north to 65 south. So you have a development of those thermocline and pycnocline, and these are the things that divide oceans into 3 zones. You have this mixed zone, and you have this pycnocline, thermocline, or halocline, and you have the deep ocean in between, deep waters actually. So this, when these layers are developed, they doesn't allow the vertical mixing actually. So there is an absence of substantial vertical mixing in the low latitude regions. So no upwelling and no downwelling will takes place. ठीक है ना. तो ये चीज को आप ध्यान रखिएगा, बहुत इंपॉर्टेंट है ये. तो ये आपके लिखा हुआ है seasonal warm because we are in the temperate zone, and warm tropical surface water because this dark pink color represents the tropical zone. Okay, so आपका ये चीज यहाँ पे अपवेल हो गई और ये चीज यहाँ पे अपवेल हो गई. इसी का ये एक डिस्क्रिप्टिव वर्जन यहाँ पर हमने शो किया हुआ है, इसको आप देख सकते हैं. ठीक है, we call it this Antarctic zone and subantarctic zone, not to remember those terms. Okay, इतना ना याद रखिए, बस अभी currents के बारे में याद रखिए. ये आप याद रखिए कि you have this the stratigraphy, according to the stratigraphy from bottom to just see this relation is very much related to your this density only actually. Okay, so your density, so you have on the bottom you have the Antarctic bottom water, that's why this is the name. Okay, now then you have this North Atlantic deep water, and then you have this thing. So if you have to put MIW, the question asked, so MIW would be somewhere in between. There are some books in which the MIW is also mentioned. Okay, it would lie somewhere in between. Understood? This is very important, that You have to remember. And then you have this Antarctic intermediate water. Okay, so this thing, you should read any questions from this part. Hello? No questions? Okay. So I shall proceed. So you have this ocean conveyor belt. Okay. Ocean conveyor belt. So this is the question that we have seen yesterday. Okay. So you can see that there are some flows that are been mentioned here. And some are your blue colored and some are your red colored. So this what these blue colors, these blue colors are the deep water zones. So red colored are the shallow water zones. ठीक है ना? This is the warm waters, warm shallow currents, and you have these deep water currents which are in blue color because they represent this cold and salty water. Yeah. And these purple locations, as you can see, in the Norwegian Sea and in this Labrador area, and you have this Weddell. These three or four prominent areas they have mentioned that represents, okay, these are the locations where this sinking is taking place. Just have a look. This is very important. ठीक है, इसको एक बार आप देखो because it is very important. Okay. So you see how it is moving. So yesterday we have done one question. So they have asked, you have this Indonesian through flow, and you have Agulhas, you have Bengal, and you have Gulf Stream. So this is the thing that it moves from here. It moves from this coast of Africa to this coast, and ultimately your Gulf Stream, and ultimately you have the sinking that takes place here. Again, it goes like this, it goes like this. ठीक है ना? अब कुछ जगहों पे आपकी क्या होगी अपवेलिंग होगी. ठीक है, तो इसी तरीके से आपके ये वाटर, अभी हम लोग ने जिग के बारे में पढ़ा. This is from the coast of Greenland up to this Antarctic coast. This much, as you can see. Okay, I hope you understood this thing. So यही आपको ध्यान रखना है इस चीज को कि आपको किस तरीके से ये मूवमेंट हो रहा है. ठीक है, एक तो आपका ऐसे जा रहा है, दिस इज द एंटार्क्टिक सर्कमपोलर. ठीक है ना? तो कुछ जगहों पे आपकी अपवेलिंग हो रही है, कुछ जगहों पे आपकी डाउनवेलिंग. And at this portion you see this south of this Africa, this is this belt, and this is this Antarctic circumpolar belt. तो इस तरीके से आपका सप्लाई होता है. Okay, so I just follows this geopolitical news. So they said that Russia wants to invade this Ukraine. This Ukraine is somewhere in this part, this Black Sea, and Russia doesn't have any port in the southern part. Yeah. That's why it has invaded one of its state, known as the Crimea, around maybe in 2014, 2014 or 2015 somewhere, which is this port in the Black Sea. And these areas, Russia have ports on this part, but you see that they are very far away first of all, and majority of the times, 4 to 5 months of the year, there is an extreme snow cover here in these parts, on the eastern parts, far eastern parts. So that's why trade is seized for the 4 to 5 months. So that's why this area is very important, very strategic for Russia, because this is the importance of this Gulf Stream and the waters that are entering from the Atlantic to the this Mediterranean Ocean, and Mediterranean Sea, and this uh, Black Sea here. This is the little bit. Okay, so this water enters from Atlantic from this Strait of Gilbatra. Okay, and this is entered into this Mediterranean, and this is subsequently entered into this Black Sea. So this is Black Sea here. तो ये चीज आप ध्यान रखेंगे कि ये जो गल्फ स्ट्रीम है, दिस इज वन ऑफ द इम्पोर्टेंट थिंग्स व्हाई ट्रेड स्टिल कंटिन्यूज फॉर द 12 months, है ना, because majority of the ports, like your ports that you have on the France coast or this Scandinavian coast, UK coast, and your Netherlands and Belgium, all these countries are here. Yes. Even your USA also, this belt of USA. So this is the role of this Gulf Stream. Yeah. That's why Gulf Stream is one of the most studied surface water current. Most studied current, because a lot of things are affected by that. Yeah. So this is one of the. This is the ocean conveyor belt, or we call it the conveyor belt circulation. So things are going down and things are coming up. Okay, so this is the surface ones, the red ones, and you have these are the bottom, in the deep oceans or the intermediate oceans. These are the things that you should remember. Now we are moving to waves and water dynamics. So we have completed up with this part. Now we are moving to wave and water dynamics. Okay, so waves are very important. Waves are important everywhere. So you study seismology, you have mechanical waves, you study optical. We consider, some model consider that light is like a wave only. You have wave model. So now you study oceanography, where there is also a wave, but the wave is of different thing. It is a water wave actually. So it is not a sound wave, it is not a light wave. It is a water wave. So now we study the wave kya hoti hai. As you know, that okay, if you have a still water and you throw a stone, what will happen? There will be a ripples that are generated, and that will radiate from the point where the stone is dropped to the periphery of the whatever, or of a lake, of a pond, of a puddle, anything. So what you have done, you have just thrown some stone. Though this stone is just as a disturbing force. वो चीजें स्टिल थी, आपने उसको डिस्टर्ब कर दिया, जिससे आपकी वेव जनरेट हुई. ठीक है ना. तो दिस इज a disturbing force. So the movement of fluids with different densities also create waves. So see, this is one of the reasons how the waves can be. This is one of the simplistic reasons how the waves can. But in oceans, it is so why you won't throw stones everywhere. But still the waves are there. Waves are there. Everybody know waves are there. So why waves are generated? It is because of this drag. It is because of this drag that exists between the air and water. Okay, so your wind flows, wind transfer the energy from it to the water, and because of this the water particles start circulating, moving in a circular path or orbits. And this is how the wave is generated in a very simplistic manner. Okay. So these waves travel along the interface. Means simple सी बात है, these waves are not deep water. These are superficial water only. I have told you about this thing. ये आपके deep water नहीं होती है. ये आपकी mainly आपके किसकी वजह से surface की वजह से होती है ना. So waves can either be generated because of air-water interaction, or because of water-water interaction, or because of air interaction. That is not important here. That is important in atmospheric waves, Kelvin waves, Rossby waves, other types of waves are there. Okay. But here your air-water interface, which we actually called as waves, and the water-water interface, which we call as the internal waves. Okay, those are the internal waves. So they are generated a little bit at depth, but not that much depth. 10 meters, 20 meters. Okay, so you see in this image, as you can expect, that water blows and it tries to form waves. So these are the waves. Okay, so you see that they have very pointed crest and rounded troughs, pointed trails and rounded curves, and this wavelength is also decreasing as we are moving from here to here, and the wave is also changing its angle. So it is moving in this direction as it is approaching this side. That is just changing this, you say, this line that represents that connects the crest is changing its angle, so it is rotating in this direction. This is known as the wave refraction that we talk about. So you have this low density water and you have this high density water. So between that low density and high density water, you generate a wave which we call as the internal wave. याद रखिएगा ये चीज internal wave बोलते हैं इसे हम. So अभी हम लोग ने definition क्या पढ़ी? Movement of fluids are gas and water only, and with different densities can also create wave. Different densities means you have different density than this. Similarly, you have low density water over which you have air, so air, because of this air drag, this thing is, this surface waves are generated. And you see in this image how this internal waves are being captured in a satellite image. These are the internal waves, and still because they are occurring very much nearby to this particular island, so maybe there would be something as a foundation because of which the internal waves are visible over the surface. So this waves, you see, so you can see those troughs you can't be able to see, but the crests are clearly visible in this image. Okay, now we talk about the wave movement. So before that, I will just add up one thing, important things, like if you don't know.
It actually both the wind driven or density driven, both. Oh, that's
And ultimately, you have it can't say density driven because of drag, of interaction between the fluids of different density. So you see the drag interaction. So it is because of this movement only. Okay. Those are not density driven. No, you can't say density driven.
okay.
Okay, because of this movement only. No, density is not a major thing.
So that means the friction between
Friction, yeah,
friction.
friction. Yes.
Yes, friction of the air produces wind.
Similar type of friction is also there. See, if the things are having same density, then there would be no disparity. They would be moving in a flow only. But if you have to generate a wave, so you see that both things have different efficiency to carry materials because of their specific gravity or density you want to say. ठीक है ना? So now it can't match up with that ocean, the wind. So it tries to transfer some of its energy when it flows over this thing. But you can't see a wave that is generated between a water of same density. This is the same density zone. The waves are not generated in this zone, in this shaded zone, but they are generated here. So this is the different density. So you have rho 2. So I would say this is rho 1 and rho 2 is greater than rho 1. So here you see that okay, these are the some uh, dense waters. These are less dense waters, and just at the contact of that, you can just generate a wave, and these waves are known as the internal wave. These are the internal waves. So when the waves are generated, they are like this.
But sir, the wind action is actually
Wind action
we
also
just
same.
read about the equipment transport. The wind action is reduced in the uh,
Ultimately, wind
30%.
is transporting things, but we are now moving more deep into how it actually does that. है ना? Those ignorance pattern all are there. All things, all construct are there. It is not something different. ठीक है ना? But we are going more comprehensively about the actual science of that. ठीक है ना?
Okay.
How the things actually move. So you have this wave. So in wave, this is the wave. So between two crests or between two troughs, ठीक है ना? This is known as the wavelength, denoted by the lambda. ठीक है? You have this. Just take it. Okay, this is the inflection line that represents okay where there is no slope. It is this 90 degree. ठीक है ना? Not 90 degree, like this part. These parts जो एक लाइन जा रही है इसको इन्फ्लेक्शन लाइन भी बोला जाता है कभी कभी. So this thing up to this crest, this is represents this amplitude. This represents this amplitude. Then you have a frequency. Okay, so I can just add one slide. Okay, so if I say that the frequency is very high, that means more number of waves are passing through an area in less time compared to this. It is passing through this area. Just imagine this is the area from which these waves are passing on. Well, that means this is having a high frequency, or sometimes nu also used to denote the frequency, and this is the low frequency. So this means the wavelength is very less here. Wavelength is huge here. This part. Okay, this means that this mu is inversely proportional to your lambda. Mu is inversely proportional to lambda. Understood? ठीक है ना? ओके, सो इन सब चीज़ों को थोड़ा बहुत आप ध्यान रखिएगा. Speed, you can easily be able to find out the speed. Obviously, sometimes we use the term celerity for the speed, which is known as a wave speed. Which is wavelength upon time. And time and this frequency is also having an inverse relationship. This is a basic idea about basic physics that I'm doing. ये सब चीज़ों को आप ध्यान रखिएगा. कंपोनेंट्स होते हैं आपके वेव्स के. ठीक है. Now we will move this wave movement. actually. So wave movement, how it actually takes place, okay, that we will see. And what are kind of wave movement? First type of wave movement is a longitudinal wave. So in this, the particle moves in a straight direction, you know, in a straight direction. It contracts sometimes, it stretches sometimes. It contracts, it stretches. It is like that. ठीक है ना? So you have this thing ऐसे नोट किया जाता है. ठीक है ना? Just see how an earthworm moves. Very similar to how an earthworm moves. ठीक है? So this is known as the longitudinal waves. So by longitudinal, because particle is moving in the direction of the propagation of the waves. So the wave is propagated in this direction. So particle is also moving in the same direction. Okay, na? Then you have the transverse waves. Transverse wave means the particle is moving up and down like this. Particles moving in this manner. Up and down, up and down, up and down. इसमें back and forth, back and forth. ठीक है ना? You have those contractions and rarefactions. We specifically use these terms.
And longitudinal waves, the steeper waves and the longer waves, maybe. What is that meaning?
Longer or steeper, you can't say. How can you say steeper? What does it steeper means?
जो जो इमेज है उसको देखकर बोल रही हूँ वो.
अभी हम दिखा देंगे, परेशान ना उसके पीछे. सब मैंने रखा, मुझे पता है कैसे नहीं समझ आता. चलो तब तक देखो नहीं. ठीक है, फर्स्ट मुझे बताना दो क्या है थ्योरी को. So you have this particle that moves in this manner. You have up and down, up and down, up and down, up and down. ठीक है ना? So the wave propagation in this direction, but the particle is moving up and down, up and down. So this means, that's why the name is transverse. Means it is perpendicular to the direction of the propagation of the waves. That's why this is. So you see that here it is moving in this direction. Here the particle is moving like this. And the third type is the orbital type, which is a combination of both this transverse and the longitudinal. So in this, it is moving front also and like this also. So it is a combination of both. So it gives effect of, okay, it is either moving in this manner and this manner. So this is the actual thing how wave moves. Oceanic waves. And this you can give an example of your primary waves. And this you have the secondary waves. Okay, so you have P and S waves that you study in seismology. Those are there. Okay. So you have P waves and you have those S waves. So things are moving up and down, things are moving back and forth, and in this the things are moving in a circular orbit. So they are also known as the orbital waves or interface waves. और इन दोनों waves को क्या बोला जाता है? These are known as the body waves because they usually transfer the energy through a body. ठीक है ना? वेव है, वेव की एनर्जी एक तरीके से, जैसे अर्थक्वेक आता है तो अर्थक्वेक से एनर्जी रिलीज होती है, तो इन द फॉर्म ऑफ वेव रिलीज होती है. आप समझ सकते हैं जब अर्थक्वेक आता है तो हाउ द रॉक बिहेव्स. फर्स्ट यू हैव दिस पी वेव्स ओनली व्हिच इज नोन एज द प्राइमरी वेव्स. तो यू हैव अ ग्रेनाइट एंड ग्रेनाइट एक्चुअली स्क्यूज होगा. ये ग्रेनाइट है, ये स्क्यूज हुआ इतना. For example, if I say it is around 5.5 centimeter, so it will become 4.94 centimeter for some time, for some instance. ठीक है ना। फिर उसके बाद वो स्ट्रेच हुआ, ठीक है ना, इट विल बिकम 5.06 फॉर एग्जांपल 04 या 06, है ना, जस्ट टेक इट 06। नाउ यू अंडरस्टैंड ना। तो ग्रेनाइट है 5 सेंटीमीटर का, इट स्क्वीजेस and then it stretches, it squeezes and stretches, it squeezes and stretches, and this is how the longitudinal wave moves. Okay, that's why at some mean strength the rocks also show elastic behavior. That's why we call it the elastic behavior, like a rubber band. The rocks are also act as a rubber band, but इतना नहीं, थोड़ा सा। अगर नहीं होगा, अगर रिजिड होगा, फुल्ली रिजिड होगा, तो वेव मूव ही नहीं कर पाएगी, वेव मूव ही नहीं कर सकती उस केस में, you know? Okay, so you see this diagram. Now you can see. Hello?
Yes, sir. Yes. Yes, sir.
है ना। तो इसका इस वाले पार्टिकल को देखो कैसे मूव कर रहा है आगे पीछे, ठीक है ना, आगे
Yes,
पीछे
sir.
मूव कर
Yes.
रहा है
You nature. Yes, wave.
ना।
Yes.
एस वेव का देखो ऊपर नीचे मूव कर रहा है, एक लाइन पकड़ा है, लेकिन ऐसा लग रहा है कि वो है, लेकिन वो बढ़ नहीं रहा है। एंड दिस इज द सरफेस वेव्स, propagation in this direction only. And there's also one kind of surface wave known as the two types of surface wave are there. One is the Rayleigh waves and one is the love waves. So they move in a elliptical manner, actually, retroelliptical manner. ठीक है ना, so this is the analogy. Okay, now you see this type of wave, orbital one ना, यही तो है ना, इसी तरीके से शो हो रहा है ना, you see this. Can you see?
Yes, sir. Yes.
ठीक है ना, so you have a ball that still is there, but it is moving in a circular manner. Actually, बस appear हो रहा है कि एक तरीके circular manner में आपकी move कर रही है wave. तो ये आपका इस तरीके के आपके circles, this is your orbital flow. ठीक है, so these waves produces ripples. These are ripples, small ripples. ठीक है ना, और ये मैंने लाइन एक्चुअली में किसी सेडिमेंट्री बुक से ली हुई है, एंड दिस इज द रीजन हाउ दोस करंट रिपल्स आर फॉर्म्ड, है ना, और वेव रिपल्स आर बीन फॉर्म्ड, दिस इज वन ऑफ द रीजंस हाउ दे आर फॉर्म्ड, ठीक है ना, ये। सो नाउ यू सी this is the diagram that I have already shown you. So you see now, this is the this other field, that all things that I have shown you, and you have the trough here, you have the crest here, you have the wave height, which is represented the amplitude only, and you have the wavelength here. So you have this wave base, this is the wave base. The wave base is the depth up to which the wave can affect the, ये वो डेप्थ है, फिर से मैं बोलना चाहूंगा, ये वो डेप्थ है जिस डेप्थ तक आपका वेव इफेक्ट कर सकती है किसी भी पार्टिकल को। If for example, if I say that the wave base, this surface is here, oceanic surface is here, you have different mud or silt particles that are lying here, so this wave will not move these particles, ठीक है ना, because the wave base is still above this oceanic floor. But if I say that the oceanic floor is here, then wave can influence that because it is lying above that wave base. और ये वेव बेस आपका डिफाइन कैसे होता है, ठीक है ना, तो वेव बेस आपका होता है L/2, ये आपकी डेप्थ होती है वेव बेस की, ठीक है ना। ठीक है ना। तो इसमें लिखा हुआ है, यू सी दैट वेव बेस द डेप्थ एट विच orbital motion ceases, the depth at which orbital motion ceases, it is mentioned here. Okay. So is a depth of 1/2 the wavelength measured from the still water level. So this 1/2 means L by 2. This L, you can say L is what? L is your wavelength. L is your wavelength. So L by 2. Okay. And because this is one of the things how the classification have been weighed, whether the wave is a shallow water wave, whether the wave is a deep water wave, or whether the wave is a transitional wave. ठीक है ना, दिस इज वन ऑफ द रीजंस. सो आपका मैं ये चीज बताना चाह रहा था. तो यू हैव दिस डीप वाटर वेव. डीप वाटर वेव में जब आप जो वेव बेस है आपका, ये आपका L/2 से ज्यादा है. You can see this image. This is the wave base, and here it is mentioned negligible water movement due to waves below the wave base. So water movement can only takes place in this part only up to L/2. ठीक है ना. तो यहाँ पर क्या है, जब डेप्थ आपकी ग्रेटर हो जाए, पानी की डेप्थ की बात हो रही है यहाँ पर, पानी की डेप्थ की बात हो रही है, अगर ग्रेटर हो जाए आपकी डेप्थ ऑफ वाटर इज ग्रेटर देन L/2, दैट इट मींस दैट इज अ डीप वाटर. मींस हमारे पास ऐसी कोई पानी का पोर्शन है जिसमें आपका कोई भी मूवमेंट नहीं हो रहा है. इससे ये सजेस्ट करता हूं आपका कि आपकी जो भी वेव्स होती हैं वो आपकी सरफेशियल लेवल को इन्फ्लुएंस करती है. सरफेशियल पे इन्फ्लुएंस होता है आपका. डीप वाटर में आपका इन्फ्लुएंस नहीं होता. आपकी विंड जो है कितना ही मूवमेंट कर देगी, ये भी तो इमेजिन करिए, कितना ही मूवमेंट कर देगी. ठीक है. तो दिस इज द थिंग. ये कुछ चीजें हैं आप याद रखिए ध्यान से. Then you have this again it is mentioned here, deep water, and you see that when the waves are approaching, ठीक है ना, this oscillatory motion, this type of orbital motion, not oscillatory, orbital motion, this you see the circle of this orbits is decreasing also because the energy is reducing. Okay, so you see that here you have a deep water wave which is depth more than 1/2 of the wave. So you see that the crests are more rounded and the troughs are also rounded. So when you move from deep water to transitional water, so you see that the deep ocean is here and you have the shallow ocean, means coast, I would say coast. Coast is here. So the water waves are moving from this direction from left to right. So when they approach to more shallower levels, so shallower levels means when the depth is from 1/2L to 1/20L. ठीक है ना, इस डेप्थ में इसको हम बोलते हैं ट्रांजिशनल. इसको हम बोलते हैं ट्रांजिशनल वेव. ठीक है ना. सो यू सी that here we don't have any surface, but where we have this brown color represents the ocean floor, and now you see that this circles are being converting to ellipses. Okay, and see here shallow water means depth उल्टा हो जाएगा. This it is mentioned here actually. These things are very important. तो आप याद रखिएगा कि ट्रांजिशनल का क्या होता है, डीप का क्या होता है और शैलो का क्या होता है. ये बहुत इंपॉर्टेंट है, याद रखना. ठीक है. नाउ यू सी how those things, those circles are now being converted into those oblate ellipsoids. And when we are approaching the oceanic floor, so how they are means they are just flattening out. They are just flattening out. So now you see it would be like this. It would be like this. It would be like this. And because this is one of the reasons why you don't see that much pronounced crest and troughs in the deep ocean, but you able to see those things in the shallow ocean because of this effect only. You see that here the waves, the crest and the troughs are so much rounded, but here it became the wave, the amplitude just increased, so you have more wave height, and now this thing have been changed into more pointed crest and rounded troughs. These are the features that we have to observe, as you can see in this diagram. And this is the more information for your references, and for the deep and the transitional wave. Okay, as you see what actually this is the wave base here, and here the wave base is somewhere here. So ultimately the over the wave base you have the ocean. Okay. So you see that the bottom oscillatory currents, so this is at, for example, this is at depth, and up to this much range I would say that this is a transitional one, this zone transitional, this zone depth deep water, and you have this particular zone which is the shallow one. So you have T, you have S, and you have D here. Okay, so you have more symmetric, regularly shaped, rounded troughs and crest, but as you move on this side those are getting pointed, and this breaking would takes place, and this is the surfing of the waves that you're able to see on the beaches actually. Okay, so this is getting affected by the base, this oceanic floor. ठीक है ना, तो इसको आप ध्यान दीजिएगा. तो इन जगहों पे ये वो जगह है where you get this wave generated landforms according to sedimentary, because this I have took from a sedimentary book. These things are mentioned here, what kind of bed forms and features you could be able to see in these zones, so you can refer to it. ठीक है ना, तो समझ में आया? हेलो,
सर सर
ठीक है, क्योंकि ये चीज आपकी सेडिमेंट्री से भी इम्पोर्टेंट है बहुत ज्यादा, मैं आपको बताऊं, इससे तो इम्पोर्टेंट है ही साथ में सेडिमेंट्री से भी इम्पोर्टेंट है. So you can read about these things what I have mentioned here on your own. ठीक है ना.
Actually, which type of question are expected from this side?
सेडिमेंट्री से आ सकता है इसमें क्वेश्चन आपका, वो मैं दिखा दूंगा कैसे क्वेश्चन उसमें परेशान. सेडिमेंट्री से आप रिलेट कर दो, क्योंकि अल्टीमेटली सेडिमेंट्री में आप जब कोस्टल प्रोसेसेस पढ़ते हो या फिर सैंडी शोर्स पढ़ते हो, उसमें आपकी ये सब चीजें यूज होती हैं, वेव जनरेटेड लैंडफॉर्म्स आपकी, तब आपकी यही सब बेसिक्स काम आते हैं, कैसे वेव जनरेट होती है, ये सब ये मैंने अभी आपको बताया. तो मैंने यहाँ पर एग्जांपल भी दे दिया आपका लॉन्गिट्यूडनल और ट्रांसवर्स वेव का, साइज्मिक वेव का भी मैंने आपको एग्जांपल दे दिया. ठीक है, ये सब चीजें आप ध्यान रखिएगा. So next you have this wind generated waves. Okay, we will take this thing in the next class, wind generated waves. So those are also gravity waves and capillary waves. As you can see here in this diagram also, some capillary waves are shown and some gravity waves are shown. So these are just the superficial wind generated ones. Then we talk about sea ash, swell, rog, fetch, tsunamis, है ना? Even tides are also a kind of a wave. Those are waves generated by the celestial bodies, gravitational pull of the celestial bodies. ठीक है ना? ये सब चीजें आप ध्यान रखिएगा. Any questions?